Okay, there we are. So with this all being said, right, you need to keep in mind the following. So with probability, any form of probability, right, starts with a scenario or what they refer to as an event. You see, so whatever event you have, it's more like, for example, if something is going to happen, right? Say you are inside a room and there are people there. Say you're inside a room. You have a room here. Inside this room, maybe let's say it's a classroom, right? And this classroom maybe has 10 boys, and then maybe it has 11 girls, right? Let's say this is the setup of this classroom. If this is the setup, right, then they can ask us various questions based on what we have here. So everything that we have here, right, we can refer to it as the sample space. Sample space. So if we're dealing with people, right, our sample space is equal to 21 because there's 10 plus 11 people, which is 21. That's our sample space. That's more like everything that we have in total. So within this sample space, we can have different probabilities. The very blunt probability is, for example, the probability of if we're going to pick a person at random, right, from this group of people, the probability of choosing a boy, right, is 10 out of 21. Reason being, there are 10 boys out of a total of 21 people. So whenever you deal with probability, right, the idea is the probability of anything, right? The probability of anything will always be equal to a numerator over a denominator. The denominator is the easiest one to explain first. So denominator is whatever total you're dealing with, right? And then the numerator will always be, let's say, what you may call specific scenario. Let's put here specific scenario, because I'm trying to use words that are just everyday words that you can remember. So whatever specific scenario they're talking about, right, over whatever total. So for example, the probability of choosing a boy. So our specific scenario here is choosing a boy. And we know that there are 10 boys. And then the total, we know these are people. The number of people that we have in this case was 21 people. So that's how we're able to say 10 over 21. So that's like the very, very basics of probability. Now, we know that with probability, it can also then go to one step further, maybe where you're dealing with 3 different kinds of things, but these things could be maybe something like sports. Let's use, like, let's say sports. Say you have sports, right? And then within these sports, let's draw a Venn diagram. We'll explain more on a Venn diagram soon, but this is a Venn diagram, right? So with this Venn diagram, I'm not done drawing it. So this is a Venn diagram. In this Venn diagram, we can have the following. Let me show it to you here. In a Venn diagram like this one, we can have, let's say, three things happen. Or let's just deal with 2 things first. Say we're dealing with 2 sports, right? Let's say the one sport is, let's say here, let's say we're dealing with sports. And let's say the one sport here is tennis. And then the other sport is soccer. Let's say the number of people that play tennis is, let's say, 38. The number of people that play soccer, let's say this is like, 22. So in a situation like this one, right, without, let's say, of explaining too much, This circle here could be representing the soccer people. Let's let this circle represent the soccer people. So if this circle here is representing the soccer people, we could say here the number of people that play soccer, right? Let's say we said they told us the total is 22 people, which is fine. Now, in this small space and in this space here, these two spaces should add up to 22. So let's maybe, I'm just choosing random numbers now. But let's maybe put 5 here. No, let's maybe put 6 here. It means here we'll have to have, I think 16 or something. Yeah, 16. Because 16 plus 6 gives you a 22. And then for the tennis, if there's 6 here, it means this has to be 32 because the people that play tennis, we know it is 38. Without explaining too much, right? What I'm trying to say is with this Venn diagram, this is how it works. You have one event over here, which is people that play soccer. You have another event over here, which is people that play tennis. Now, in the middle where the circles meet, that's a place where people play both sports. So this is saying there are 6 people that play soccer and tennis. This is saying there are 16 people that play only soccer, 32 people that play only tennis. So the 16 and the 6 people here make up a total of 22, as we know it should. And then the 32 here and the 6 here make up a total of 38, because those are people that play tennis. So when we're thinking of this definition of probability, the probability of anything is going to be equal to a specific scenario over the total. So let's say here they're asking for something like the probability. If they're saying if someone is chosen at random, chosen at random, what is the probability that they choose? What is the probability that they choose a person that, then they can have different scenarios. This could be question number 1, question number 2, question number 3. So they can be asked, what is the probability that they choose a person that plays soccer only? And then they can ask for maybe plays both sports. And then they can also then ask for someone that plays tennis only. You see, let's spice things a little bit.
The spice, oh God.
Okay, no, yeah, let's no, not spice per se, but let's say you just have people. Let's say you have people that play none, right? People that play none, you can maybe have, let's say 3. So that number will be out here. You see. So let's make that plays none. It's because in this Venn diagram, things have to be working together. This is saying people that play both, people that say play only tennis, people that play only soccer, people that play none. So when you're answering these questions, right, obviously the first thing you're gonna ask yourself is, in this particular question, it says here, what is the probability that the person plays soccer only? So playing soccer only, you have 16 people, because this number 16 here is representing people that play soccer only. Out of a total of 22 that play soccer, only 16 play soccer only. So the probability that a person plays soccer is going to be equal to 16 people that play soccer out of a total of we know that we're dealing with 38 plus 22. That's going to give us a 60. You see, which is what we say, the probability of anything is going to be equal to whatever scenario they're talking about divided by the total. So the scenario they're talking about here is people that play only soccer. So you footwear that play on the soccer. It's 16. The total people that we're dealing with is 60 people in total, of which this your calculator can give it in its simplest form, whichever way it's going to give you. So the calculator for this question, let's see, 16 over 60. What does 16 over 60 give you?
16 over 16.
Yeah,
Yeah,
16
hold
over
on.
60 in the calculator.
My calculator was far from me. Give me a second. I didn't think
Yeah.
we'd do calculations.
I mean,
16 over 16. 1? Oh, 60 over 16. My bad.
What's the fraction that you
4 over
calculated?
15.
4 over 15.
Yeah.
Yes, 4 over 15. That's the simplest form of this fraction. And then, depending on what kind of answer they want, sometimes they can want it as a percentage or whatever. So here we know this, we can say 4 over 15, as you said. Let's put red here. Where's red? 4 over 15. You see, this is also as a decimal, 0 point whatever, but let's not worry about that. So any probability answer you get, if you're gonna write it as a percentage, right, you just multiply by 100. So this is gonna be equal to 26.67% if they ask for a percentage. But for probability questions, you can normally just end off with the fraction in its simplest form, and then you'll be good. Cool.
Okay. Well,
yeah. For the others, same idea. Probably that someone plays both sports is this number here. There's only 6 people that play both. So the scenario is people that play both, right? You have 6 of those. And then out of a total of 60 people, so this is going to be 1 out of 10. It's just going to be 10%. You get it?
I get it.
Yeah. And people that play tennis only, you're going to have here 32 people out of a total of 60. So 32, 60. In its simplest form, you're going to get 8 over 15. 8 over 15. People that play none, I mean, we saw it was 3 here. 3 people out of 60. Like that. Yeah.
I guess it makes sense and I'm looking at it now.
Mm-hmm.
And then when it comes to the question, I'm just never quite sure as to which format to use. I don't know if that makes sense.
Yeah, it makes a lot of sense because with probability questions, they all normally boil down to the same thing, but the way it starts is not always the same. You see, it's not always the same. So what you call? So with all this being said, we can expand more on what you may call on probability, or we can have this as like the very beginning or the basics of probability, if you will, you know. So the thing now with probability is you need to understand the theory behind the questions that they'll ask you. So some of the basic theory that you need to know is when it comes to probability, your different scenarios, right? Or as they refer to them as events, your different events, right? They have different characteristics. So what I'm trying to say is in probability theory, right, there are certain events that will be referred to as independent events, and then there are other events that are referred to as mutually exclusive events. So let me give a breakdown of what those words mean, because fortunately, right, those definitions that were going to the formula, the words that I just mentioned now, right, they both come with formulas, and those formulas are formulas that you then use for different probability questions depending on what they would have asked. So in a situation where we know that we're dealing with independent events, let's see here. In a situation where we're dealing with independent events, right? Let's see what independent events tells us. When we're dealing with independent events, right? Independent events have a formula. The formula basically just says the probability of one thing happening multiplied by the probability of the probability of one thing happening, right? The probability of one thing happening and another thing happening at the same time. Let me write the words actually. The probability of something happening and the probability of something else happening at the same time. This will always be equal to the probability of the first thing multiplied by the probability of the second thing. I'll repeat, the probability of two things happening at the same time. If we are dealing with independent events, the probability of two things happening at the same time is going to be equal to the probability of the first thing multiplied by the probability of the second thing. You see, so that's for independent events. With independent events, it's almost like things like saying, this is a way of saying that the probability of one thing happening and the next thing happening is just you multiplying the probability of the first one multiplied by the probability of the second one. So when you think of what we've spoken about here, right? As long as this formula balances out, because remember this thing here is a number, and then this is also a number, and then this is also a number. All these are numbers, you see. So questions that may speak of independent events, you need to think of this formula. Or there are cases where they'll ask you to prove that something is an independent event or not an independent event. You'll just need to put numbers into this formula. If it balances out, you know you're dealing with independent events. And now this is something you've bumped into already, right? But with the other definition or the other words that you need to know, it's words like mutually exclusive, mutually exclusive. So with mutually exclusive events, right? These have this have the following formula. The probability of A and the probability of B. So the probability of A and B happening is going to be equal to 0. The probability of A and B happening is going to be equal to 0. This is for mutually exclusive events. So that means that it's two events that cannot happen at the same time. You see, independent events, those are events that can happen at the same time. When I say events that can happen at the same time, I'm referring to, let's say, let's think of a what you call, let's think of a simple scenario in probability. So it's almost like, for example, if you're talking about certain things that cannot happen together. Like, for example, if you're dealing with what now? I don't think of a light scenario. I don't want to go too deep because this is 2022. Everything must be fact checked. Otherwise, I was literally about to no, yeah. But anyways, an example of something like mutual exclusive event. There's two things that cannot happen at the same time. So, for example, it's maybe a scenario where you're talking about, let's say, the probability of it raining, the probability of it being cloudy, or the probability of it being sunny. So those are three things where you cannot necessarily say they can occur at the same time, you know? For example, if it's sunny, then I mean, it's not going to be raining. If it's raining, then it's not going to be sunny. If it's cloudy, then it's not necessarily raining at the time and it's not necessarily sunny. So certain things can only happen alone without, let's say, something else happening. Those are mutually exclusive events. You see? So those are mutually exclusive events because with mutually exclusive events, the word is just tell you mutually exclusive. For independent events, these are things that can happen together.
I have a question. Will the questions, I have a question. Will the questions in the exam actually say like independent or mutually exclusive? Or they give you a hint like prove that it's mutually exclusive, or like how would those go?
Yeah, so with those, as you said, right, sometimes they will tell you something is mutually exclusive and independent event or whatever. If they tell you, it just means they mean you should know, you should use one of these formulas, whatever they're telling you. If they don't tell you and they ask, then you use these formulas to say yes, you're dealing with a mutually exclusive event, or yes, you're dealing with an independent event. For example, as we said, as long as the numbers balance these formulas, it means that it will tell you what kind of an event you're dealing with. So normally in a question, they'll give you different pieces of information. They will give you, for example, the probability of A happening, and then they'll give you the probability of B happening. Once they have done that, they can then ask you, are these events independent? And then you would need to know, okay, for me to test whether they're independent or not, I need to multiply them together and see if the answer I get is going to be equal to the probability of A and B, because these are the numbers that would have given you. This is something you would have been given, or something you would have needed to like work out beforehand, because you'll just throw that number there. You will have this number, right? So after doing these two calculations, A, probability of A, the probability of B, when you do those calculations, they should just give you this value here. If they do that, then it means whatever you've done is leaning towards you working with independent events. For mutually exclusive events, it's the same thing. If you're not check if something is mutual, if events are mutually exclusive, then you need to have the probability of A and B, whichever way you'll find it. And then you need to see if that number is a zero. If that number is a zero, then yes, you're dealing with mutually exclusive events, meaning the two things cannot happen at the same time. Meaning, for example, if you had it here as zero for some odd reason, this would automatically be mutually exclusive events, because there are no scenarios that would be, there are no events that would be taking place at the same time. It's more like a weird, strange, what you call exception. If this is a zero, technically we know we're dealing with like mutually exclusive events. So that's the idea with mutually exclusive events and independent events. So these formulas, you can see, they are specific to what kind of an event you're dealing with. But then in a situation where you are not necessarily what you call dealing with a specific event, there's a main probability formula that can help you, do what you need to do. So the main probability formula that you need to know is called the addition rule of probability. The addition rule, the addition rule of probability of probability. So the addition rule of probability is also a formula that's on your formula sheet, fortunately. It will tell you that the probability of something or something else is going to be equal to the probability of that first something plus the probability of the second something minus the probability of A and B. So this formula, the one way to be able to like explain it is to use the nature of a Venn diagram. Because if you know the way a Venn diagram looks, it is able to tell you why this formula always makes sense. Because if you have two events, right? Event number one, I'm going to use a different color here. Event number one, and then maybe you have another event, which is this one, right? Event number two. So in a situation like this one, if you look at what the formula says, the formula literally says the probability of A, so this is A here and this is B, right? So A or B. The thing is with probability, right? The word or increases your chances of getting something, That's what you want to remember. The word or in probability does not have the same effect as or in English when you speak the language. Because or in English, it means you either choose the left side or the right side. You see, but then or in probability means when you're choosing, both options are in the same pool. So usually when it comes to probability questions that need you to work out the probability of something or something, you usually have a higher probability because the probability of A or B, this is what a Venn diagram looks like when you think of the probability of A or B. The probability of A or B, you basically need to take into account everything that is A, which is everything here. And then you need to take into account everything that is B, which is this here. This is everything that is B. Once you've done that, so you see it says add the probability of A plus the probability of B, and then subtract the probability of A and B. You see, so the probability of A and B is you subtracting the middle, because you see you counted the middle twice. You see here you say the probability of A, which is the whole thing, the probability of B, which is the whole thing, and then you have to subtract the middle once because you counted the middle twice. So that's the probability of A or B. You would need to take whatever number is here plus the number in the middle plus the number at the end there, add them all up, and then you divide by whatever total you are dealing with. That's how you would get the probability of A or B. Now that formula is on your formula sheet, you see. And this formula basically allows you to also work with your other formulas. So when I say it allows you to be able to work with your other formulas, I basically mean that you being able to work with your other formulas, right? You need to, for example, if you need this probability here, right? You could, for example, get it in this formula because there's a place for it here. Now, if you need this also, you can see there's a place for it there. If you at some point need something like the probability of something happening, there's a place for it here. If you need the probability of something else happening, there's a place for it over there, you see. So that's what you need to keep in mind. Otherwise, yeah.
Mm.
Mm-hmm.
Jeez.
Mm-hmm. Yeah. 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 Yeah.
Is there a subtraction rule?
Pardon?
Is there a subtraction rule?
Not necessarily. It's just a name. Because you see here you're adding, but
Okay,
here you're
it's just an
subtracting. So it's just a name for this formula basically. But with
I guess I was
probability,
thinking in terms of trig, like reduction and all of that.
yeah, no, I get you. I get you. I get you. So in terms of probability, right, these are like the smallest building blocks of probability. Because from here now you will then get other different diagrams like a tree diagram and things like a two-way contingency table. But the basics of the probability, it somewhat remains the same, it somewhat remains the same. The basics of it remains the same, which is one thing we want to keep in mind for now without worrying too much. You see?